Good evening friends, study with Apala Engineering and General Geology Parvin Singh book। तो हम लोगों का चैप्टर 18 चल रहा है ग्राउंड वाटर इंजीनियरिंग के तहत, है ना। और इंजीनियरिंग ग्राउंड वाटर ऐसे नॉर्मल तो हम जानते हैं कि हाँ कैसे ग्राउंड वाटर पढ़ना है, लेकिन अगर हम इंजीनियरिंग के तहत पढ़ रहे हैं तो उसका बाकायदा एक सिस्टम है, उसके तहत उसकी ड्रिलिंग होती है, उसमें उसकी प्रॉपर जांच होती है कि किस तरह का अंडरग्राउंड स्ट्रक्चर है, उसमें फिर क्या क्या इंस्ट्रूमेंट होंगे, क्या क्या, और फिर उसको बनाने के लिए ग्राउंड वाटर को चेक करने के लिए क्या क्या चीज़ें हैं, प्रोसेस हैं। ठीक है, तो साइंस है तो हर काम सिस्टमेटिक है, सिस्टमेटिक है तो नियम है, नियम है, कायदे हैं, कायदे तो भाई थ्योरी है, थ्योरी है तो फार्मूले हैं, फार्मूले हैं तो डायग्राम, साइंटिस्ट नेम, ये सब चीज़ें रेडी रखनी पड़ेंगी। ठीक है, तो हम लोग पहले पढ़ चुके हैं फ्लो इन एक्विफर, ठीक है, जिसमें परमेबिलिटी हो चुका है हमारा, हाइड्रोलिक कंडक्टिविटी आज से होना। तो शुरू करते हैं। हाइड्रोलिक कंडक्टिविटी इन ग्राउंड वाटर जियोलॉजी और हाइड्रोलॉजी इज द क्वांटिटेटिव मेजरमेंट ऑफ फ्लोज ऑफ वाटर्स इज जनरली एक्सप्रेस्ड बाय द टर्म्स hydraulic conductivity and rather than permeability. The hydraulic conductivity K may be defined as the flow velocity per unit hydraulic gradient. It is expressed as meters per day or meters per second. Darcy law, इसमें डार्सी लॉ लग रहा है, साइंटिस्ट हैं डार्सी, हेनरी डार्सी, a French engineer, pronounced in 1856 a relationship between rate of flow of water through a porous mediums to other parameters such as hydraulic gradient and length of the column of the mediums. His experimental observation has been established as Darcy law and forms fundamental equations in the flow of groundwater. According to this law, the rate of flow of groundwater through columns of saturated sand is directly proportional to the difference in the hydraulic head at the end of the column. Second, inversely proportional to the length of the columns. So mathematically here formula है जो कि उनका V is equal to K H1 minus H2 का whole upon L. So where V indicate flux velocity or specific discharge, K hydraulic conductivity, H define D1 H1 to H2 मतलब है difference in hydraulic head, मतलब जो उसकी ऊंचाई होती है उसको ये मेजर करते हैं। L length of the column, तो hydraulic gradient, so the difference in hydraulic head at 2 points divided by the length is often called as hydraulic gradient, L, small l, so that the above equations may be rewritten as V is equal to KL. So it is known that in a pipe flows the conditions which is analogous to flow in a porous medium. The discharge Q is given by relationship Q is equal to VA. So where A is the cross sections areas of and V is the velocity and specific discharge, and from the above equation the relationship of discharge to hydraulic conductivity is easily established. Q is equal to KLA. This relationship is of fundamental importance in groundwater studies, and here Q represent discharge and is expressed as discharge per unit times, such as cubic meter per days or gallons per minutes. K as usual in the hydraulic conductivity and indicates the quantity of water that whilst flows through a unit cross-sectional areas per unit times under a unit hydraulic gradient at a specified temperature. The value of K range from 0.5 meter per day to 200 meter per day or even more. Transmissivity, this term was introduced by Thales, ये भी साइंटिस्ट हैं, in 1935 to express the capacity of an entire aquifer to transmit water. The coefficient of transmissibility, T transmissibility, was defined by Thales as rate of flow in gallons per minute through a vertical sections of an aquifer's first foot wide, extending the full saturated length of the aquifers under a unit hydraulic head. Types of flows. In general, the groundwater flows through the interstices is of a laminar type, although the turbulence flow also occur in certain situations. In the laminar flow, the water droplets and drops movement very slowly in a continuous steady ribbons like fashions through the pores and other openings. In such a case, water moving laterally through the thickness of an aquifer's flow in layers, there being no intermixings of waters from overlying layers. The turbulent flow is a characteristic of subsurface streams and involves a complete intermixings of water molecules in which move in an irregular fashions. Artesian aquifers. An artesian aquifers has already been defined as the confined types of aquifers in which the contained water is under such a hydrostatic head at that once tapped, the water will rush to the surface and may rise above the ground to a certain height. In fact, the term artesian water is derived from the abundance of such well in the Artois regions of Central Europe. In some cases, where hydrostatic pressure is comparatively less, water may approach the surface in a well without actually overflowing. Such types of wells are called sub-artesian wells. Artesian waters is a good source of water supply in many regions of the world. There are at least 3 geological considerations that need careful observations during planning water supply programs from artesian water resources. Existence of a suitable type of aquifer. An artesian's aquifers must necessarily be enclosed at the top and base by impermeable layer. Impermeables यानी कि जहाँ से गुजरता नहीं है ना, कोई भी चीज़ आर पार ना हो. तो layers of the aquifers must be suitable inclined to create sufficient hydraulic head. The piezometric surface must lie well above the ground surface. Monoclinical stratas and broadly synclinal basin type geological structure are considered ideal as artesian basins whence these are overlain and underlain by impervious layer. In-Tec areas, theoretical levels, piezometric surface, artesian wells, impervious and permeables. Suitable condition for location of artesian well. Discharge conditions. Artesian aquifers being overlain by impermeable strata must have naturals exposed at the surface somewhere in the catchment, in other words, and their rims, and must be exposed to get a replenishment from the precipitation. It is obvious that such an exposure should be in areas of sufficient rainfall, so that enough quantities of water is available for recharge. In some cases, artesian aquifers may get their recharge from other types of subsurface free water, where the free water aquifer is hydraulically connected to such a confined aquifer. Absence of leakage. In artesian aquifers, there is always a possibility of leakage point due to localized development of fractured zones, reduced impermeabilities of the confined layers, or connections with the other subsurface water bodies. Such points will effectively reduce the total hydraulic head available in ideal condition. Artesian conditions are created in rock by a number of ways. These may be due to original deposition and subsequent deformations, such as foldings and faultings, further both fresh water and mineralized waters may be obtained from artesian wells. In thicker artesian aquifers, the lower zones may contain even salt water. Artesian wells, also called flowing wells, are chiefly used for water supplies and irrigations. In some cases, they form an important source for the chemical industry. Hence, study of artesian sources aimed at rational planning for water supply programs forms an integral part of water resources management. A successful planning programs involves collections and coordinations of all data on geology, hydrology, hydrogeology, climate, and proposed extractions method. There are very diverse types of artesian basin, varying in areas, so types of rocks, numbers of water-bearing formations, geological structure, and depth from the surface. It is therefore always necessary to first know the nature's geological structure and petrological character, as also silent hydrological feature of the artesian belt. With the help of a test borehole spreads systematically over entire region under investigation. Similarly, locations of a natural drainage area for artesian water is also important, since it has a significant bearings upon the yield of the wells in the region. Such drainage areas includes artesian springs and other means of ground seepage. In volcanic terrains, conditions for artesian water aquifers are sometimes available where sloping lava layers are overlain and underlain by impermeable layer of clays and other materials. So IMP impervious LF क्या है, ये डायग्राम बनाइएगा. लावा फ्लो एंड आर्टिशियन कंडीशन इन वॉल्केनिक टेरेन. ठीक है, IMP LF और IMP. थैंक यू. प्लीज गिव अ पॉजिटिव रिस्पॉन्स.